Welcome back to our channel. My name is Oluwasegun, and today I'm going to be walking you through another interesting video titled Sentiment Analysis of Product Review. Actually, it's a natural language processing machine learning project, and I'm going to be walking you through from beginning to the end of the project. So kindly stay with us. So I'm a data scientist, and let's assume this scenario. So whereby let's assume I just landed a job, a role as a data analyst at Flipkart, where I can't where they gave me a bunch of unrefined data. So Flipkart normally constantly gathered product reviews from all their products, and recently they became curious as to what could be done to the data to enhance their operations. So the manager approached me and asked on the potential improvement. So using this unrefined data. So one of my key suggestions was to develop a model capable of classifying reviews autonomously as either positive, negative, or neutral. So this actually, by integrating it into the website, they may not need to manually read every review to gauge how a particular product actually performs. So this is a very good way of applying machine learning to companies. So, and this is a typical project that I've worked on. So I just try to obtain an open source data to demonstrate something pretty close to what I did in the project. So in this project, basically you're going to be learning 8 things. So and the first one is to how to efficiently load and manage a sample of big data memory. Actually, in the real world, most of the data that you'll be working on will be really huge, not all this data that we usually use for open source projects. So most of the data, they'll be really huge. So in that case, you may not need to develop your model using all the 100% of the data. So I will show you how to load a sample of data, so a sample of big data into your Jupyter notebook, and then use that to develop your model. And then you may later, if you have more power, you have a more powerful computer, then you may go on to load more data and the likes. But your data, your model shouldn't be affected so much by the amount of the data that you use. So although we know that machine learning project, machine learning models are data sensitive. So, but in this case, I'm not going to be loading all the data. All right. So, secondly, I'm going to be showing you how to techniques to counter categorical variables and visually explore data through visualization. So, and then I'm going to show you the methods to create word clouds from textual data, offering a way to have a visual insight of what you have within your data. Then best practices for splitting data into training and test set for model validation. Then how to effectively vectorize test data for machine learning models. Then how to steps to train classifiers like Multinomial, Bayes model, and RandomForest. Then how to interpret your model performance using the metrics such as accuracy score and classification report. These are the 2 main parameters that we usually use to study how our model actually performs. Then the selection of the model that you may eventually use to deploy, to use to integrate to your website and stuff like that. So join me on this project as I demonstrate practical data science techniques that can drive real world impact. And don't forget to like, subscribe, and hit the notification bell to stay updated with our latest tutorials and projects on Damks Analytics YouTube channel. So let's go. Vamos in Portuguese. So actually, this is the source where I got the data from. So feel free to download the data and then try to do the project alongside with me. So I think this is the best way to learn, right? All right. So the next stage right now is the data pipeline. Now, before I start any machine learning project, any machine learning model at all, the first thing that I do is to come up with a handwritten data pipeline. So I try to get paper and pencil, and try to draw out, sketch out the flow of the project. So this helps a lot. This helped me to go offline while developing model, because that is very, very easy in most of the projects that I've handled. So try to have a sketch of the pipeline that will show the step, like an high level overview of how of the processes of the steps in the project. So in this case, I have load the data set, then process the test data, extract features from the test data, okay, such as the the columns, the features that we will be using for our predictors and the target. Then train a machine learning model, evaluate the model, then make predictions on the new data. So this is a very high level data pipeline. So if you want a more concise one, in the project that I talked about, that I worked on, is for sure just more concise and more comprehensive than this. So because in that I needed to trash out, okay, what if I use these machine learning algorithms? What are the cons and pros of this algorithm? So why should I and why shouldn't I use these algorithms and stuff like that? So those are the things that you have to put down in your pipeline, so that by the time you start writing the codes, you flow much better. So you do less of thinking. You just consult your pipelines, and then you try to implement things. So yeah, if things do not work out the way you plan, then you try to edit, to modify your pipeline, right, before you even go back to the code. So that is the way I operate. So that might not work for you, but that has been working for me for the past 5 years now in my experience with the data science project. All right. So the next step now in the project is actually to import all the libraries that we'll be using in the project. So for sure, we're going to be using pandas for the data manipulations, and we're going to be importing train test. So from the scikit-learn model selection. So if you are someone that's been working with machine learning, so I don't think you should have any problem as to where I got all these things from. So by simply typing them the way I type here, you should have the same result. So the only issue that you may have is that probably you've not installed some of the modules, so which you can easily just do by typing. If you use Anaconda, then Anaconda on Google, Anaconda name of the module, so it will come. So you can install that in Anaconda prompt. So if you have any problem with that, you can always check on the website. So this video is not basically to show you how to do that. So these are all the libraries, the modules that we're going to be using for the project. So we're going to be using RandomForest algorithms. We're going to be using the Multinomial. So these algorithms, they're going to be using some metrics such as the accuracy score and the classification reports. So, and of course, Matplotlib for visualizations. And this guy also, word cloud. So we also use this for visualization in natural language processing project. This is interesting. So then after that, the next thing is to load the data. So like I said earlier, that you need to download the data from the link that I showed you earlier. So after you downloaded the data, so just import the data, and after your pd.read CSV, then you add this part of the code to it, and this sample function, this load this fraction of the data. So this implies a 10% 10% of the data will be loaded randomly. Not that it will select from 1 to 20 or something. No, no, no. So it is selected randomly. So that's why this is very good. So it will not be that biased. So it will select randomly 10% of the data and then load it to the Jupyter notebook to our memory. So which means that I'm not working with the whole 100% of the data. So if you like, you may increase it to 20 to 50% or something like that. So feel free and see how your model actually changes, how it performs. So by the time we do this, then just go down, then data.add. So, and this is what we have in our data. So these are the main features: the product name, the product price, the rate, the review, the summary, and the sentiment feature. So you determine the one you want to use, and of course we're not going to be using all the columns. So we're going to be using the ones that we know that is more related to our business questions. So these are the things that you've got to fish out in your data pipelines. So with this now, with my detailed data pipeline, I know already the columns to be used for my model. So with that, I just go ahead and try to implement the columns that I need for my model, and not necessarily, not at this point that I will start racking my head and then start thinking which one should I use. No, 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 no. You should have a laid out plan already, like a pipeline for your project prior to writing codes. So now the next step in the project is to visualize the sentiment distribution. So the next step is to count the frequency of each category of sentiment in the data. What do I mean? In this way, this is the sentiment column, sentiment feature. So we want to see the distribution of how many neutral, positive, or negative review do we have. So, and I'm gonna try to use Python, value count function, so which will return both the index of each category and the values. So we can use the tool to make a bar plot. So with this line of code, this is what does the this actually extract the frequency of each unique value in the sentiment column. So, and then it will return the index and the unique value, the unique category in the sentiment column. So, we can use a bar chart to show that. So, where our x-axis we simply call the index, then the y-axis we use values. So then every other stuff are just aesthetics. So then by the time you run this cell, you should have something pretty close to this. So where we can see clearly that there are more positive reviews on Flipkart products than negative and neutral. So which means that, the company is, visually speaking, you can say that the company is doing well, right? So, but this percentage is also huge. This is more than 2,000 reviews, so that are negative. So these are things that needs to be worked on, that needs to be further monitored. So I see, is the positive review increasing or the negative review? So these are the things that the company got to monitor very closely, and to be able to do that, they need a model that can autonomously classify each of the customers review. So, and that is what we want to do now for the company. So the next step in the project right now is to visualize the customer's review summary using word cloud. So this review summary is actually the main text, that the customers wrote in let's say in the box where you put your reviews. So these are the tests that the company actually received from the customer. So we want to use word cloud to visualize this test. So word cloud is very interesting. So with word cloud, we can visually evaluate, we can visually judge how the distributions, the words that we see in the word cloud. So how we can use that to visually uh, say that, okay, cool, seems the company is doing well, seems it's not, and stuff like that. So we have to create, and what are the steps? So we have to create the test variable, which is basically the test data to be visualized, okay? Then we have to set the parameters of the word cloud. Then the matplotlib show function is then called to visualize the test. So, what I did, so the steps, number one is to create a test variable like this called test, okay? So where we join all the reviews together, just like we merge them all together to be together, and then from that we can drop none, all right? Then we call word cloud, so where we specify the parameters of the word cloud, so such as the width, the height, so the background white. Then we use the generator function where we supply this text that we've already generated, that we've already matched together. So we supply that variable name, all right? So then we go on to visualize using prt.imshow. So the word cloud, this here is supplied. Then you can use this is the way I usually produce the using the interpolation of bilinear. So when you run that, you should have something close to this. So, and from this, we can say for ourselves, this is excellent, good product, working, love it, worth it, really, once more, good product, nice, bad, money, awesome, quality, stuff, best. And so you can see, so the uh, the form weight of this test actually shows us the frequency, how frequent. So with this now we can say that we have more, the frequency of good is the highest. Good, so is the highest, which implies that most of the reviewers usually had, oh, good, nice product, or good product, something like that. So, and that is what we can see from this word cloud, which of course agree with this initial chart where we can see that there are more positive reviews than negative reviews. So now we get the next step is the features extraction and split the data into train and test set. So we select the features for our models such as the predictors and the target variable. So in this case, we're going to be using summary column as the predictor and sentiment column as the target variable. All right. So then we proceed to split the data into both the training and testing set of 80 by 80 by 20. So, and how do we do that? So the first thing is to make sure that you drop the num rows. If you want to test what I'm talking about, just try to remove this line of code and then run it and see what you have. You're going to have error message because the model is sensitive to none. So you've got to drop none rows. That is the rows consisting of missing data. You've got to drop them. So before proceeding to train testing of your data, all right? So now we specify the X so as the summary and the Y as the target variable. So then we call train test. So when we split the data into both the train and test set. So what are training set? So the training set of data is the one that we use to develop our model, and then we use test set, to test, validate out our model performs, such as the unseen data. So you can call training set as the seen data and the test set as the unseen data for the model. So by the time you run that, and everything goes on well without any error message, then you know that, okay, cool, your data has been splitted into both training and test set. So in this case, we use test size. So if you increase this to 3 or 5, if it's 5, which means you are using 50-50. So you are using 50% of the data for training, 50% of the data for test set. But that is not the conventional way. So the usual way. So sometimes I use 80/20, sometimes I use 70/30. So those are the two options that I've used for most of my models. Okay, so the next step now is the vectorization of the test data. So we now have to convert the data into the format that the algorithms, that the computer understand. So this is called vectorization. So both the train and test set have to be vectorized. So this is a crucial step in machine learning models that use test data. I mean, in natural language processing. So we've got to vectorize our data. So, and how do we do that in Python? So number one is to use the count vectorizer. So we initiate this variable called vectorizer. So by calling count vectorizer, so with this variable now, so we can fit the train set and the test set. So by the time we fit that, it means that we've already transformed, we've already vectorized the data into the format that the algorithms can take as input for the modeling. So the next step now is to proceed into fitting our model. So now we begin the training. So using multinomial based classifier. So after we get our data ready for training, after we've already vectorized the data, then we proceed to initiating the model. Then supply the training data to the model for it to learn. So that's why they call it machine learning. So the model learns from the data you supply to train the machine. So it will go through the data and learn some patterns and stuff like that, based on the inner working of the algorithm that you are using to model your data. So we initiate this called NLP classifier. Okay, so and then after we've done that, then we fit this by supplying the vectorized data. So after that, then you just run this cell. So if you have this something like this appearing, it implies that, okay, the computer has learned. So using the data that you used to train the model, then you can go on to make predictions and check the accuracy of the model by calling predict. So you predict the sentiment class of a particular preview by using the data that the machine has learned. Okay, the training set. So then you can also check the accuracy score by supplying the test and the predicted target class. So the other things are just aesthetics. So by the time you run this cell, you should have the accuracy score, which is right here. So we have about 0.896, which is approximately 89.64. So This is the not too bad, it performs well. Then this is the confusion matrix. Okay, so like the classification report, and I'm going to be showing you how to explain this result clearly. So the next step is to train the random forest model. So this is also classifier. So it's always good to develop at least 2, 3, 4 models and see how each of them performs. So with this, that's what we call model selection. So with this, the performance of each model, after you've analyzed them, then you go with one with a much balanced trade-off pattern. So that is what I usually do in my project. So in this case, I'm developing Bayes classifier and random forest. So we do practically the same thing that we did earlier for the model. So we initiate, then we call random forest classifier, where we estimate, we supply the number of estimators, so then the random state. So this is basically just to have the same result each time. We run this code, then we fit the training vectorized data. So, and after that, you try to run this cell. So, and if something like this appears, it means that, okay, cool, your the machine has learned again using random forest classifier algorithms, and then you can you can go ahead and try to predict. Okay, check the accuracy score and the confusion matrix, the classification report. So with that, by the time you run this cell, you should have something close to this. And we can see right here that random forest performs much better than the Bayes classifier. So, but this accuracy score is not enough for us to conclude that the random forest perform much better than the Bayes classifier. So that is where the classification report is very important in interpreting and selecting the model that you're using for the production. So now we have to make a prediction on the new data. Now we have a model, okay, that anybody can use to predict the sentiment class of a review of a customer on a particular product. So, and to make a prediction on new data, we've got to write a short function for each model. You know, we have 2 models now, right? So the Bayes classifier and the random forest. So the functions take the customer reviews as test, okay, then vectorize the input, then pass it to the already trained model to return the class of the sentiment. So that is how is this a positive review, a negative review, or neutral review? So something like that. So I created a very short function here, so that takes the test, the review of the user, of the customer. Then after then, it moves on to vectorize, transform the text. Like I said earlier, that the text, the data has to be vectorized to the format that the algorithm understand. So then after that, we move on to predict. All right, then we return the prediction variable. So that is for our Bayes classifier. Then we do the same for the random forest classifier. So, and let's try to apply that. So let's say the input test, the review of the customer is, it says really good, bad product. Okay, this is a very confusing review, so really good, bad product. Then we let's say we initiate this variable called predicted sentiment. So where we call this the first model inputs the test, then we generate the output. All right. So, and when we run that, we have this. Okay. So what this is for the first model. Okay. So let me try to use random classifier now, where we have this RF. Okay. So let's see our random classifier. Actually, it classifies it as negative. What if I remove this? Now it classifies it as positive review. Let me do the same for the base classifier, and let me see if it's gonna be okay. Yeah, it also pick it as positive. So the initial one was very confusing. We have really good, bad product, you know. So that is confusing for the computer. So, and which implies that even for human being, it sounds confusing, kind of, you know. So, but which implies that we can still improve this model. So now, how do we update our model performance based on the accuracy score and the conclusion matrix? Okay. So now we have various parameters here that are very good for model interpretation. So I'm not going to be going through each of them, but I'm going to read out my own summary of how the two models actually performed. So the model performs for the base classifier. So the model performs well in identifying positive sentiment, but it struggles with neutral sentiment due to low recall and F1 score. So the precision and the recall are very important, but by the time you have kind of discrepancies between the two, the F1 score helps to make conclusion as to whether the model can recall what it has learned. I mean, okay, for the last one, they put it negative. For the next review, how sure are we that it will be able to remember that it's negative, stuff like that. So overall, the weighted average F1 score is 87%, indicating a much decent performance across all classes. While for a random forest classifier, the model outperforms the Bayes classifier in all metrics. How? It achieves higher accuracy, okay, which is 92.74%. For Bayes classifier is 89.64%. So, and better precision, recall, and F1 score across all classes. It shows a similar pattern for struggling with neutral sentiment, but performs exceptionally well in identifying positive sentiment. Now, this is the problem of the two models. Struggling with neutral class could be related to the portion. We only use 10% of the data to develop our model. So probably we have lower proportion of neutral events in that 10%. So that could be the issue. That could be the reason why the two models struggle to classify neutral very well. So it shows a similar pattern of struggling with neutral sentiment, but performs exceptionally well in identifying positive sentiment. Overall, the weighted average F1 score is 92%, indicating superior performance compared to Bayes model. So yeah, so that is basically what I want to share with you in this model. In this project. So feel free to edit some part of it. So this is how I believe that you could learn more. So try to change some parts of the model and let me know if you have any comments any questions. So just put it down in the comments below, and don't forget to like, share, and subscribe to our channel, so that each time that we upload new video, new project, so you'll be able to you'll be notified and improve your knowledge of machine learning. So thank you so much, and see you in the next video. Bye. My name is Adibaya.